So the next session is offline first Flutter, building resilient apps for unreliable networks. So please welcome Akansha.
Konnichiwa, Tokyo. Namaste. I hope you all are doing well. Can we have some raise of hands or a shout? You all are doing well? Okay. Everybody got food? Everybody is full? Okay. So I would like to first thank you, all of you, that you are here listening to all these speakers, amazing speakers that we have. And thank you so much, Flutter Ninjas, for inviting me all the way from India. And it's my first time in Japan. And it's been 4 days that I am here. I explored Japan a little bit. It's a beautiful country with the beautiful people. Thank you so much. So let's talk about how you can create offline first Flutter applications. So before starting, I would like to introduce myself. Hi, I am Akansha. I am from Delhi, India. I am a software engineer at AutoNation. It's a US-based company. They are one of the largest car selling companies in United States. I'm also a community person. I am a Google Women Techmakers Ambassador, the organizer for Flutter Flow Developer Group New Delhi, the organizer for FlutterConf India, and the co-organizer for Flutter Delhi. Okay, so why offline first matters? Why do we need to create offline first applications? Would anybody like to answer?
No internet.
Okay, so you don't have internet, that is why? Okay. Yeah, that makes sense. That is why we all are here, to create offline first applications, right? And this is why it matters the most. Imagine you are in a plane and you want to write a journal. Okay, you have an app, you are trying to write a journal, and then this screen appears where it says error, you are unable to connect to the server. You are not able to save your journal, basically, right? You will be frustrated, and then you'll close your app, right? Is it? Okay. So now, if we talk about offline first, you have an offline first version of this app, okay? Now you write your journal, it saves that journal into the local database, and then once you land, you get connected to the internet, and then it syncs automatically. So as a user, you don't know what happened. It just works as if it was working as for an online application, right? So these are the important things why offline first matters. You have to be aware that there may be some areas where we don't have reliable internet, maybe a subway, right? When I landed in Japan, I got an eSIM with unlimited data so that I can go anywhere I want, because otherwise I'll be lost. And your core features of the application should work offline, right? And the user experience has to be smooth, even if the internet is non-existent. Is offline first necessary? We talked about why offline first matters, but is it really necessary? As in, should your whole app be working in an offline situation? Or certain features of your offline, certain features of your application can work offline? What do you think? What is the best way? So you should have 3 things in mind when you are creating your offline first application. You have to ask yourself these 3 questions. Which features of your app made as offline first will improve the user experience? Is this feature possible to be made as offline first? which data should be persist on local storage device. For example, it can be your favorite articles or your bookmarked content, right? And when you are creating your offline first applications, you should design it in a way that there is no internet as default, right? You should think like there is no internet, and then you should be able to, you know, design your application if you are creating it for an offline first. Now, this is a very simple flow diagram that I have. You have a method call, then so method call is basically your action. As a user, you want to do something. You are going to first check the connectivity status of your app. If your app is connected to the internet, then you are going to get your data from the remote repository, and then you are going to sync that sync your local database with that new data that you get from your remote repository. If your app is not connected to the internet, then you are going to get your data from the local database, and then you are going to use your app. It's that simple. So if it's an online application, you are going to get your data from the cloud, and if it's an offline first application, you are going to get your data from the remote repository as well as the local database. Now, there are three things which are the most important when it comes to offline first applications. One is the data availability, data synchronization, and conflict resolution. So when we talk about data availability, we need to think about, can users access that meaningful content even without a network? We are going to deep dive into each of these one by one. Then if we are talking about data synchronization, then how are we going to sync those offline changes that we have with the backend when we are back online? Conflict resolution, what happens when the same data is changed both offline and online at the same time? There will be a conflict, right? So let's deep dive into each of these one by one. Data availability, what it means. So when we talk about data availability, it means you should be able to use your app offline without any errors or blank screens. You should be able to load your data instantly from a local storage database like Hive or SQLite or Drift. You should be able to avoid dependencies on online APIs at your app startup because you are creating an offline application, so there should be no dependencies on the online API. What are the best practices? You should be able to use your local database as a single source of truth. And what I mean by that is, I'm going to explain you this in a little bit. And then you should be preload your important data during the onboarding of your app. And you should be able to show the offline indicators so the users know what data has been cached. Now, let's try to understand this using a simple flow diagram. After this, I'll show you the code. So for example, you have an app which is continuously monitoring your network connection, whether you have internet or not. If you have no internet, then you can, give a feedback to the user that there is no internet connection. And the other way is, if you have an internet connection, you can just be back online and then sync the pending data with the server. Now, if your app creates an HTTP request, there can be two cases. One is you get a status code 200, which is a success. You cache your data and you load the data from your local database. The other is the network exception. So if you get a network exception, then obviously you are not getting any data from your remote repository and you are going to load the data from the local database. So this is what I mean by having a single source of truth as your local database. So every time you are getting or you are fetching the value from your local database only, whether it is a success call or it is a network exception or a server exception, right? So now if I want to fetch a data from an HTTP request and I'm getting a 200 success code, I'm going to write that data to the local database and I'm going to fetch the data from the local database and then update the UI. In the same way, if I'm getting a client exception, I'm going to fetch the data from the local database. So here we can see that our local database is acting as a single source of truth. Now, how to set up the local databases? Apart from these three, we have many more local databases that we can use. But if we talk about these three, Hive, SQLite or Drift, you can see that Hive is a lightweight key value database made for Flutter and Dart. And if you want to deep dive into Hive, you can scan this QR code. It will lead you to the documentation of Hive. If you want to use SQLite, you can use it. It is ideal for handling structured relational data like user profiles, tasks or orders in a Flutter application. You can also use Drift. It's a reactive persistence library for Flutter and Dart which is built on top of SQLite. So if we deep dive into the code, is it visible till the end? Okay. So if you want to set up your local database for your offline first application, then what you can do is for SQLite, you can just add SQLite to your Flutter project in your PubSpec YAML as a dependency like this with a path provider, and then you can create a database helper class with all your CRUD operations. So I'm not diving deep into the aspects of all the CRUD operations here, and if you want to learn more about this, I will give you the access to the doc from here. You can take a screenshot. If your internet is working, you can directly go by scanning this QR code right here. It will lead you to this documentation that I was showing you. And if you want to use Hive for your key value storage purposes, then you can just add Hive into your project in pubspec.yaml as a dependency, and then initialize it into the main.dart and define a data model for the type of data you are going to store like this. And then you can create a Hive box and model. If you go into the documentation of Hive, you will be able to see how you can create a Hive box and model. So this is one example of how you can do it. Now let's go back to this and let's talk about data synchronization. So when we talk about data synchronization, what we mean is that all our offline actions are stored locally first. When connectivity is restored, the app automatically syncs with the server. So our local database has to be in sync with the remote repository, right? So when the connectivity is restored, your app will automatically sync the local database with the remote repository, which is the remote server. And the syncing should be resilient and retriable even after your app restarts. So the best practices can be, you can queue the operations, mark them as pending, use a retry logic and exponential backoff for failed syncs. You can also consider a background sync with work manager or time.periodic. So if we go back to the doc, you will see that if you want to sync your data with a remote server, you can use a connectivity plus package on pub.dev. You can add it in the pubspec.yaml as a dependency, and you can use the connectivity class to detect whether your device is online or offline, and then you can queue up your tasks for syncing later. So now if we go back to this, you can see here, for example, you want to add a note to your application. That can be considered as an action, and what we will do is we will have that status as pending, and we will give it as a unique identifier. We will give the ID as a unique identifier. Then we are going to create a post request, mark that entry as status as syncing, and then we are going to, we have two options. One is the success one and one is the server error. If we are going to go down the success road, then we are going to say, okay, that the status is synced and you can delete your entry from your local database. If you get a server error, then you can retry that mechanism on a particular interval. So In step 3, we are going to manage the syncing conflicts. So I already told you that we have to resolve the conflicts that we get when we are syncing our local database with the remote repository or remote server. So when you are syncing, your app must resolve the differences between the local and remote versions. Without conflict resolution, you risk data loss or overrides. And the best practice can be you can include timestamps or version fields in your data model, and you can strategize based on last write wins, which is the simplest one. You can merge your changes, or you can ask the user for manual resolution. So if we are managing those conflicts, then this is how you can add timestamps to each update and apply the latest change when you are syncing your local database with the remote repository. And you can create a logic to decide whether you want to override or merge those changes when the app comes back online. Then the step 4 is you have to implement a background sync. As I told you in my first example, as soon as you land right on the airport and you get your internet connectivity back, as a user, what you want is whatever data you stored in your local database, you want that to be automatically in sync with your remote repository. So for that, we can create a Flutter work manager. We can add that work manager package to schedule our background tasks like this in the dependencies, and then we can set up our sync jobs. You can configure the work manager to periodically check for changes and then sync with the server like this. You can create a callback dispatcher, and you can tell your work manager to execute those tasks and sync your local database with the remote repository. So it will, for a user, it will work as if that the user was using this application in an online mode only and not the offline mode. So again, if you want to access the doc, you can scan this QR code. That doc has all the code which you need when you are going to create your first offline Flutter app. Now let's talk about network awareness. So for example, you have a team of developers who are not experienced enough to create an offline first application, or maybe there are some features of an application in which you don't want to implement the offline first approach. Then what you can do is, for a user, you have to implement a feedback mechanism where if your feature doesn't support offline support, then you can show a snack bar saying that you have to check your internet connection, or you can have an alert dialog saying that, hey, the internet is not working, you might want to retry, and things like that. So that is what we call as network awareness. So according to the statistics, if there is no offline support, then 20 to 60% of the users are more likely to uninstall your app. And if there is no feedback channel, then 2x or 3x increase in 1-star reviews, which we don't want, right? I don't want anyone to give my app a 1-star review and say, hey, your app is not working. Why is it not working? There is no offline support. It's so frustrating to use your app. I don't want that. So if you don't want that, please implement offline support in your applications. Not all features, but some of the features that you want are essential to your app. So as a key takeaway, your app should delight users even when disconnected. Arigato gozaimasu. Thank you so much. If you want to connect with me, you can scan this QR code. In this QR code, you will find my link tree, which has all my socials, LinkedIn, my website, Instagram, everything. Thank you so much. Arigato gozaimasu.
So we have time for Q&A, so any question?
Thank you for the talk. It was really interesting and useful. Yeah. I have a question. What do you think about solutions that provides offline first functionality from out of the box? For example, Firebase or AWS Amplify, so you can just use all services and they will do everything but without any steps from your side. They just prepare the queue of things that you did, and when you have connection again, they push everything to cloud again.
So I haven't tried it, but I think Firebase real-time database gives you that support to create offline first applications. So yeah, I haven't tried the other options yet, but yeah, that can be one solution because I know Firebase real-time database do that.
Yeah, there's even not only real-time database. Almost all products that works with data.
Yeah.
Yeah, and storage provides opportunity to, like if you, for example, download something and your connection is interrupted, so after you get connection again, it will resume from the same place where you were interrupted.
Yeah.
Thank you again.
Thank you.
Thank you for giving us a very great presentation. I have one question about, you introduced some local database such as Hive, SQLite, and Drift. I'm familiar with the first local database, Hive and SQLite, but I'm not familiar with Drift. How do you think about using Drift for our development? What's the difference compared to these local other databases?
Okay, so have you used SQLite?
Yes.
Yeah, so Drift is based on SQLite only. So it's a reactive persistence library that is built on top of SQLite. So it's kind of similar, but it is an extension of SQLite that you can say.
Okay, gotcha.
Yeah.
Thank you.
Thank you.
Thank you for the great presentation. It's a kind of a similar question of previous question. I usually use Realm as a local database in making native mobile application. What do you think Realm as a local database with Flutter application?
With the native? Realm with the native application? You are
Realm with Flutter application.
Realm with Flutter application, I haven't tried it, so I can't comment on it. But yeah, I would love to check that. Thank you so much for the suggestion.
Okay, thank you.
Yeah.
Any other question?
Do you think for the best that needed to good to practice that backend and that and Flutter, because the data model will be same and generic at the same time, and that would be benefit for the offline.
Can you come again with the question?
Because you are talking about the thinking, so I think, do you think that if backend and Flutter use the same model, same data language, that will be bad?
If backend and Flutter use the same module, would it be beneficial? That is your question, right? Yeah, that would be beneficial, obviously, because we have to communicate with the backend in some way or the other, right? If you see in my presentation, most of the time I talked about the data synchronization with the remote and the local database repository, and also whenever I'm going to use APIs as a backend service, then I'm going to be benefited if they use the same thing. So yeah, that would be beneficial. yeah, you can explore more ways of how it will benefit you and which backend service you are using. So that depends on that as well. Thank you.
Any question? Good. So thank you, Akansha. So let's give a hand to Akansha.